I would like to bid a good day to Dr. Riza. Our team consists of 5 members and we are going to talk about process safety management elements related to the Husky Energy Refinery explosion and fire. The Husky Energy Refinery explosion and fire had occurred on April 26, 2018 in Superior, Wisconsin. The sequence of events which led to the explosion had started when operators were conducting periodic maintenance on the Fluid Catalytic Cracking Unit or FCCU. Operators had proceeded to shut down the FCCU in order to carry out maintenance process. This process involves closing the valves in the FCCU. However, during this process, one of the valves was corroded and could not prevent the catalyst from entering the reactor. Simultaneously, a surge of air had flown through the unit and reacted with the hydrocarbons. The mixing of air and the hydrocarbon had led to a large explosion.
Hi, my name is Anafana. From our group discussion and analysis, we found that Husky Refinery explosion accident lack of 5 missing PSM element. The first missing PSM element is the process hazard analysis. Based on PHA 1910.119E1, the process hazard analysis shall be appropriate to the complexity of the process and shall be able to identify, evaluate, and control the hazard involving in the process. However, from the Husky accident, Husky clearly violate this code as the safeguard recommended does not match with the complexity of the process. CSB stated that the Husky refinery did predict the mixing scenario in their PHA. However, they recommend using the separate control system, which in fact unable to control the mixing scenario. Next, PHA 19.10.119E1 also stated that PHA shall include the consideration of the extent of the process hazard. However, from the CSP investigation, Husky Refinery does not include all mode of operation in their PHA. Therefore, Husky Refinery unable to identify the process hazard during the non-routine operation which are the incident occur. Here are some recommendations for FCC or Husky Refinery to improve their process hazard analysis. First one, to cater the ineffective safeguard, FCC should evaluate the impact or consequences of possible failure and design appropriate safeguard matched with the impact level. Next, FCC should also evaluate how the failure of control affect their employees' safety and health. Second, FCC should consider all mode of operation, including the non-routine operation, such as unit standby, when performing process hazard analysis.
Hi, my name is Muhammad Hakimi bin Sazali, and now I will talk about the next missing element, which is the operating procedure OP. So according to OSHA, the employer must develop and implement written operating procedure that provide clear instructions for safely conducting activities involved in each covered process consistent with the process safety information. So based on case study given, which is the Husky Energy Refinery explosion and fire, the Torrance FCCU was nearing to an end of its operating cycle and was scheduled for maintenance. Therefore, the management should have produced an operating procedure that would have helped its employees to identify any defects to the unit before the actual shutdown of the unit was conducted. This operating procedure would have also identified the defect in the SCSV and determined whether the unit was fit to be shut down or not. So as a conclusion or recommendation, FCCU startup procedures must be updated periodically, especially during turnaround operations.
Based on the process safety management of highly hazardous chemicals, part number 1910.119D states that employers shall complete a compilation of written process safety information before conducting any process hazard analysis. The compilation of written process safety information is to enable the employer and the employees involved in operating the process to identify and understand the hazards posed by those processes which involves highly hazardous chemicals. This process safety information shall include information pertaining to the hazards of the highly hazardous chemicals used or produced by the process, information pertaining to the technology of the process, and information pertaining to the equipment in the process. The process safety information element is divided into three subparts: 1910.119D1, which is information pertaining to the hazards of the highly hazardous chemicals in the process; 1910.119D2, which is information pertaining to the technology of the process; and 1910.119D3, which is information pertaining to the equipment in the process. One of the missing PSM elements in the Husky Energy Refinery explosion and fire was 1910.119D3, which is information pertaining to the equipment in the process. In this case, the Husky Energy Company was solely relying on the SCSV to maintain a barrier between the hydrocarbon and the air side of the SCCU during non-routine operations. Although the SCSV already had built-in erosion protection suitable for the unit's design life, if proper PSI pertaining to the equipment was conducted by the employee or employers of the Husky Energy Refinery, the management would have realized that instead of relying on the SCSV as the only means of barrier between the hydrocarbon and air, the management could have installed an additional backup system that could have taken over the function of the SCSV in case of an emergency. As a result, if an additional valve which served as the backup system for the SCSV was installed, this backup valve would have maintained the barrier between the hydrocarbon and air, and the accident could have been avoided.
Now, the missing PSM element here would be the lack of mechanical integrity. Upon inspection, the valve in the FCCU had been eroded and could not contain the catalyst. This problem mainly occurred because of the lack of regular maintenance and inspection. Furthermore, the lack of durability of the material used to construct the valve could have been also an issue. Management should have adhered to OSHA 1910.19119J Act, which is the Act of Mechanical Integrity. Some of the main elements of this act includes having proper inspection and testing. The frequency of inspection and tests of process equipment should be consistent with applicable manufacturer's recommendations of the one. Next, quality assurance in the construction of new plants and equipment has to be conducted. The employer should have assured that the equipment fabricated, in this case the valve, is suitable for the process and ensures purity of the material used to make the valve. This could have ultimately avoided the